I am Sujan. Now I am going to explain about the topic which comes under the theory of computation. The topic is partial derivatives of the regular expression and finite automation construction. Explore the fascinating interaction of the regular expression and the finite automata through partial derivatives. This powerful approach revolutionizes automata construction and compiler design. Introduction to regular expression. First of all, what is definition of the regular expression? Regular expression are the patterns used to match character combinations in the strings. They are ubiquitous in the text processing and the searching. Next, which are the components which the basic components that include laterals, meta characters and operations. These elements combine to create complex patterns. Which are the applications we are using this in the regex is used in the text editors, search engines, and the programming languages. It's essential for pattern matching and validation. Next, the formal definition of the regular expression. What is the formal regular expressions? Firstly, the basic symbols theta, empty set, and the summation empty string, and a single character from a foundation. In the operators, union, concatenation, and Kelly star are the primary operators that we use in a formal definition of the regular expressions. What are the recursive definitions? Recursive regular expressions that are defined recursively using basic symbols and the operators. Next, what are the partial derivatives of regular expressions? Firstly, the concept, secondly, calculations, and thirdly, significance. In the concept, partial derivatives decomposes regex into a simpler forms. They represent possible continuations after matching a characters. In calculations, derive using recursive rules based on regex structures. Each derivative corresponds to a state transition. In significance, partial derivatives provides an elegant method for constructing finite automata from the regex. In next, Brozovsky derivatives algorithms. In this, firstly, input, derivation, and acceptance. Firstly, in the input, regular expression and the input strings are provided as input to the algorithm. In derivation, iteratively compute derivations for each input characters. This process simplifies the regex. In the acceptance, if the finite derivative accepts summation, then the string is affected by the regex. Next, constructing finite automata from regular expressions. Firstly, states, transition, and acceptance. In the states, each unique partial derivative becomes a state in the automation. It ensures a compact representation. In the transitions, transition between the states that are determined by character-wise and partial derivatives. They are almost determined by their characters, and this captures the reject structures. In the acceptance, states corresponding to nullable derivatives are marked as accepting. This preserves the regex semantics. Next, what are the properties of partial derivatives of regular expressions? Firstly, the first property is finiteness, closure, and ACI equality. We can know about the finiteness. In the finiteness, the set of the partial derivatives for any regex is a finite. This ensures the termination. In closure, partial derivatives are closed that under union and concatenation. This simplifies computations. In ACA equality, associatively, communicatively, and incompetence of the union simplifies the derivative comparisons. Nextly, applications of the partial derivatives in the compiler design. We can see the diagram which are compiler designs. In this, the steps are given. Firstly, lexial analysis. In lexial analysis, efficiently tokenize input based on the regex patterns. In syntax parsing, construct parsers for the con- context-free grammars using extend techniques. In code generation, it will optimize the pattern matching in the generated code. Nextly, what are the advantages of the partial derivative approach? Firstly, efficiency. Secondly, incrementality. Thirdly, theoretical elegance. In the efficiency, we know that partial derivations often lead to a smaller automata. This regulates it faster Pattern matching. In incrementality, automata can be constructed on the fly. This follows the dynamic regex processing. In the theoretical elegance, the approach that provides the unified view of the regex that automata, this depends on our understanding. In the practical derivations, the derivations are given in the given figure. We can see that. Next, limitations and the future directions. What are the limitations and future directions that comes under this? Firstly, complexity, quantum computing, and AI integration. In the complexity, we know that some rebate patterns can lead to a exponential growth optimizations that needed to these cases. In quantum computing, the exploring quantum algorithms for reject processing, this could offer exponential super speedups and this AI integration incorporating machine learning to optimize regex construction.